Okay, sixth grade, our objective today is to graph linear functions with a table. So yes, we're going to do a little review right now of what a function is, but our goal for today is to learn how to graph a linear function with a table. Okay, let's go through the warm-up. I want you to tell me whether you got yes or no for each of them, and then if you did the puzzle, we'll go over the answer to it. Okay, Jackie, we'll start with you on number 1, yes or no? Good. Nathan S., number 2. Good. Grace, number 3. Good. Ray, number 4. Good. Drew, number 5. Okay. Skylar, number 6. Good. Number 7, Josh. Good. Mike, number 8. Number 9, Kevin. Good. Number 10, Neil. Shane, number 11. Good. Number 12, Greta. Good. Okay, before I ask you what the answer is, any questions on 1 through 12 in regards to how do you know whether it's yes or no? Okay, so what did the baby porcupine say when it backed into a cactus? Shane? Good. Hi, Ma. Why would he maybe say that? Hi, Ma. Mike?
Because the cactus is spiky like a porcupine.
Good. The cactus is spiky like a porcupine, or what's the other thing that maybe, or what's the other reason maybe? Neil? Well, I wouldn't say that. What's the other reason that maybe he could have been thinking? Okay, this reason isn't maybe not as common, but would you say? Yeah, maybe he was afraid and he needed his mom, right? Could be another thing. I thought both when I read this initially. Anyways, that's a really good practice with what a function is and what it is not. Okay? I need you to take out practice 8.1. Miss Wingrove's going to go through homework with you. I know mapping function was a little bit confusing to you, but she'll go over that if you guys need her to. It is different. Changing it up. Yeah.
So that's okay.
Yeah.
Just use different terms than what you did in
Yeah.
class. Any more questions about the mapping diagram? I think once you see that, it's really self-explanatory. And then last one, 13C, is it a function or is it? Yeah, why not? Okay, so no, because 75.
Yeah.
Right. 75 is paired with 1002 and 1018. So, any more questions? Hopefully pretty easy. Thumbs up, thumbs middle, thumbs down.
Good. Yeah, in the mapping diagram, we will not have on a test, it will not say make a mapping diagram. Ms. Wingrove will be giving you the quiz, your first quiz for this chapter. She will not have that on your quiz. Okay, it'll be what we talk about in class, or she'll make it really difficult. She made the 7th graders quiz for today difficult. We'll see how they do, right? You sure, guys, you're good? Okay, before we move on to notes, so you can go ahead and open up your notes to 8.2. Can someone tell me another name for X? What's another name for X? Drew? Good, input. What's another name for X, Ray? Good, domain. What's another name for X? Abigail? Begins with an I, and there's a song about it. I don't know if you guys know that song. It makes me feel old if you don't know that song. Amberly? Independent, I-N-D-E. You know what I'm talking about. I can't sing, but I would if I could. Okay, another name for Y. Jackie? Good, range. Josh? Good, output. And what's the other name for Y? Grace? Good, dependent. So make sure you know 3 names for each of them. You will see that on your quiz and or chapter test for this chapter. Gio? We're not doing more with the function man today, sorry. You missed the fun. I know. I'm sure you were sitting at home and you were angry that you weren't here for the function man. I'm glad you watched him though. Yeah, he was cool. He was like this. If we could actually do that with our arms. Nathan M? For X and Y? For X, independent, domain, and input. For Y, output, dependent, and range. Got it? Okay. All right, so 8.2, we're going to find solutions of equations in 2 variables. And more specifically, we're going to learn today how to graph from a table. This is not my favorite. I don't think Ms. Wingrove likes this that much either. But you need to learn that there's different methods and ways to graph a linear function. In case you forget how to do it the way that we'll show you eventually, which is the shortcut way I call it, this is a good backup to have. Okay, we're going to start with, it's a warm-up, but we're going to do this together. I want you to change this to linear combination. In algebra next year, I think it's in chapter 5, you'll learn more about linear combinations, which just means, is this ordered pair a solution of the equation? Is it a linear combination? You're going to say yes or no. So let's do this together. For number 1, if we have 0, 4, how can we test whether, Kevin, please turn around, whether this is a solution of this? How can we test whether it's a solution, Greta? Awesome. I want everyone to put your input and output or your X and Y underneath 0 and 4, and let's see if it is a solution or not. Or in other words, is it a linear combination? So we have 3 times 0 plus 2 times 4, which is equal to -8. 3 times 0 is 0, so we have 0 plus 2 times 4 is 8. Is 8 equal to -8? No. So it's not a linear combination. So your answer is no, because it's not a solution. Sorry. So no. Okay, I want you to try number 2. I'm going to walk around. It's very, very easy. I just want you to remember that this can be called a linear combination, or it can ask you, is this a solution? Okay, so try number 2, and if you guys do well, we're going to move on to the next example. So you're plugging in your X and Y, and you're determining whether yes or no, it's a linear combination. All right, so let's plug number 2 in. So we have 3 times negative 2 plus 2 times negative 1 equal negative 8. Well, we don't know. Negative 6 plus negative 2. So does negative 6 plus negative 2 equal negative 8? Yes. Yeah. So negative 8 equals negative 8. Yes. Number 2, the ordered pair is a linear combination for this equation. And yes, that's a linear function. Questions? Greta? Yes. Yes. Yep. That's why it's a linear combination, because there could be many or several combinations. Maybe there's just one. And we'll definitely talk about that a lot next year. Anyone else? Okay, let's go to a definition, and then we have a first example. So definition that's squeezed right underneath where we just wrote linear combination. Linear equation, this is kind of common sense, an equation whose graph is a line. So linear equation, an equation whose graph is a line. What'd you say, Mike? Well, it's just so easy that it, maybe doesn't. Yeah, we need to have a function man for this lesson. We do. Okay, first example. Okay, so we have an equation that is y equals 2x plus 3. So the directions here tell us that we need to create a table of values for the equation. Now, I do not care what values you use, but your book and standard worksheets are always going to use -2, -1, 0, 1, 2. Raise your hand if you have graphed with a table before. Well, not that many of you, just a couple. Okay. Those of you that did your teacher have you use these numbers? Don't know, maybe? Okay. Okay, that's fine then. So just so you know, FYI, a lot of teachers and books and worksheets will have you use these numbers. I'm going to use them in class, but really you can choose whatever values you want. So I'm going to write out the first couple, and then we'll do the rest of them mentally. If x is -2, let's plug it in. We have y equals 2 times -2 plus 3. So all I did was take this x value, and we are plugging it in for the x value of the equation they give us. So Shane, what's -4 plus 3? Good. So what does this column mean? Do you guys know? What does that mean? Abigail? Good. So just write it as an ordered pair. So -2, -1. So let's graph that. In other words, let's plot that. Where does -2, -1 go? Grace? Good job. 1, 2, 3. Here's quadrant 3. -2, -1 means over 2. So to the left 2, down 1. There's our point. So -2, -1. We have a smiley face point. So there's our point. Okay. So let's go to the second one. I'll write this one out too, then the other ones we'll do mentally. So y equals 2 times -1 plus 3. So order of operations tells you multiply first and then add. So Josh, what's -2 plus 3? Good. So then make sure you write it as an ordered pair. -1, comma 1. Kevin, can you tell us where that goes? Where does -1? Good. Good job. So quadrant 2, -1, up 1. Okay. Okay, so let's do the rest of them mentally. If you plug 0 in for x, what is the y value? If you plug 0 in for x, Nathan S., what's the y value? If you plug 0 in for x, what does y equal? Good, 3. 2 times 0 is 0. 0 plus 3 is 3. Write that as an ordered pair. And Alexis, where do we put 0, 3 on our coordinate plane? Opposite. It's always x, y. Good. Over 0, up 3. So it goes right there. Good. Okay, if we plug 1 in for x, we have 2 times 1 plus 3. Gio, what's 2 times 1 plus 3? Good, 5. So we have 1, 5. Steve, when we graph 1, 5, where does it go? Good. Over 1, up 5, it's in quadrant 1. Okay, then the last one, Ray, what is 2 times 2 plus 3? Good. So we have 2, 7. Does that one fit on my graph? No. Now, could you put it up there? Yeah, we could put it like right there, but we're not going to. So let's connect our smiley faces. Here is our linear function. So let me ask you this question. Is that a positive or negative linear function? Is it positive or negative, Shane? Okay, why? Awesome. From left to right, I showed you this yesterday, but it was very, very brief. It's increasing from left to right. So since your line is increasing, it's a positive linear function. Until we get to slope, you really don't need to know that, but it's good to tell you that in advance. So it's a positive linear function. Questions on that? Okay, we're going to, oh no, we better not actually. Okay, let's go to number 2. I was going to skip it, we can't. Okay, so number 2, let's put in for our x values, -2, -1, 0, 1, 2. So let's use the same values. Now, this is a little bit tricky because there's a negative in front of x. So what do you think is going to happen when we plug -2 in for x? Joseph? It turns into 2. So we have y equals -x, which is -2 minus 2. So if you're plugging a negative in and it's already negative, you have 2 negatives back to back, it's going to turn to a positive. You remember that from chapter 1? So we have 2 minus 2, which is 0. So your first value is -2, 0. So I'm going to write that as an ordered pair. And when we graph that, Michelle, where does that go? That's it. Good. Over -2 and up and down 0 because it's -2, 0. So it's right on the x-axis at -2. Okay, let's plug -1 in. We have y is equal to -1 minus 2. -1 is 1. So, Greta, what's 1 minus 2? Good. So we have -1, -1. We're going to go over 1, down 1. So there's -1, -1. Okay, let's do one more. If you plug 0 in, what is -0 minus 2? Abigail? Good, -2. So you plug 0 in, you get -2. So when we graph that, we have 0, -2, over 0, down 2. And 3 points is enough. On your homework, I want you to do all 5, but because of time right now, let's just do 3. Connect your points. Is that a positive or negative linear function, Drew? Nope. Why? Do you know why it's negative? Okay. Can anyone explain why is that negative? Evan? Good. So look from left to right, which is the way that you read. It's kind of like when we're running or driving down a hill. From left to right, it's going down. Do you see that? So if you go this way and it goes down, it's negative. If you go this way and it goes up, it's positive. Does that make sense? Okay. Anyone else have questions on that? David, we're in the notes on page 4. Soon on page 5. Oh, in the back where it says pre-algebra. Okay, let's go to number 3. I wanted to do more, but this is the last one we'll do for now. Okay, so number 3. This might be too hard of a question, but does anyone remember what kind of function is this? Oh, a lot of you. Neil? Yeah, begins with a Q or a P. Good job. Shane? Good. A parabola. What's the other name? I'm impressed. Wait, say that again. I really like that. You're close. I like the translation, though. Grace? Say that again. Yep, quadratic. So very close. So parabola or a quadratic function. All right, do you know why? No. Shane? Awesome. Because it's to the second power. You will learn how to graph these by hand next year. If it's to the second power, it's a parabola. I love how you guys say that. Or quadratic function. Okay? So let's do this one. So let's use -2, -1, 0, 1, 2. If you plug -2 in for x, and I'll write one of these out, what is -2 squared plus 3? Abigail. Awesome. What happened to the -2, Abigail? Awesome. Good job. -2 times -2 is positive 4. So 4 plus 3 is 7. So -2 comma 7. Drew. Okay, did you listen to what I just said? Okay, listen, ready? -2 squared. -2 times -2. A negative times a negative is a positive. Remember what I used to do in chapter 1? You have two markers or two fingers back to back. It makes a plus. Okay? Okay, what about -1 squared plus 3? Nathan S. Good, 4. -1 times -1 is 1. 1 plus 3 is 4. So -1, 4. Jackie, what about 0? 0 squared plus 3. Good, 3. 0 squared is just 0. 0 plus 3 is 3. So 0 comma 3. Mike, what about 1 squared plus 3? Good, 4. Josh, what about 2 squared plus 3? Good. Why, and this might be too hard of a question, maybe not, why are these numbers repeated? Skylar? Awesome. Because the negatives are going to cancel. Nathan S. It is a parabola. Good job. So let's graph. -2, 7 is right here. -1, 4, I'm just going to go through this quickly, is right there. 0, 3 is here. 1, 4 is here. 2, 7 is somewhere up here. Here's our nice, beautiful U-shaped graph. It's positive. It's actually, I love that, I know. Parabola. I don't know if I can say that. It's actually called concave up because it's positive. You'll hear that more next year. But yes, there's our quadratic function. Nathan. Yep, good job. If it was flipped upside down, it's a negative quadratic function. Yep. Quabola. Is that what you want me to say? I can do that. We'll have Miss Wingrove do that next week when she's teaching you guys more of those. Any questions? Okay, now ideally, I do want to do number 4 in the closing, but I'll save that for tomorrow. Tomorrow, I'm going to teach you kind of the same thing, but the equations are not going to be in y equals form. So they're going to make it a little bit harder. So I'm going to have you do a little bit of 8.2. So open up your homework packet. So 8.2, and you have a couple minutes to start. I want you to try numbers 1 through 4. Nope, nope, nope. I just need to think here. And 9 through 12, 17, and 24. Okay, so I need to explain. So first thing I need to tell you is for numbers 9 through 12 and 17, you need to use a table. So I'll say that again. 9 through 12 and 17. If you do not use a table, you're not going to get full credit on your homework. Second thing, everyone look at number 11. Everyone. Look at number 11. I wanted to go over this, but I didn't have time. It's a fraction. I know you know how to multiply fractions, but what I want to ask you is, what table values could we use so that you do not get a decimal? So in other words, what can you multiply that fraction by so we get nice answers? Josh, what do you think? Nope, if you multiply by 2, you'll still get a decimal. Geo. 4. So let's use -4, 0, and 4. So for number 11, only use those 3 points because the graph is small. Now, yes, you can use 8. Yes, you can use -8 because if you look at the denominator of a 4, 4 goes into 4, 4 goes into 8, etc. Now, do you have to use nice answers, nice numbers? No. For all the other tables besides 12, I want you to use -2, -1, 0, 1, 2. I want you to figure out for number 12 what numbers that you could use so you get nice answers for y. Okay? That was a lot of stuff. Does that make sense? Okay, so what I did on mine is I made a table right next to the graph. So I want you to do the same thing. There's plenty of room to make a table. If you can do it mentally, do it mentally to find what y is. If you need to write out the work, that's fine. Any questions? Okay, and then please make sure that your homework is